Right now, three fault systems on opposite sides of the Pacific are moving at the same time. In Japan, the Japan Meteorological Agency has logged a cluster of offshore tremors near the Nankai Trough, the same subduction zone scientists have flagged as overdue for a magnitude 8+ rupture. In Alaska, the Aleutian Arc recorded a 5.4 magnitude event just 11 days ago. And in California, while every camera, every headline, every breaking news chyron was pointed at Japan, the Cascadia and San Andreas systems quietly produced over 200 small earthquakes in a single week along the Ridgecrest-Coso corridor. 200 earthquakes, 1 week, most under magnitude 3.0. Almost none of them made the news. That's not a coincidence you should ignore. That's called an earthquake swarm, and according to the United States Geological Survey, swarms like this one have preceded some of the most damaging quakes in California history. So while the world's attention was locked on the Pacific's other side, the ground under 39 million Americans started sending a signal. Stick with me for the next 10 minutes, because I'm going to break down exactly what's happening beneath California right now, why the Pacific Ring of Fire is talking on both sides of the ocean at once, and, using real data from the USGS, Caltech's seismological laboratory, and Japan's JMA, what history tells us happens next. Let's start with the numbers, because numbers don't lie. The swarm in question centers on the Coso volcanic field and the Ridgecrest fault network in Kern and Inyo counties, roughly 150 miles north of Los Angeles. Over a 9-day window, seismographs recorded 214 individual events. The largest hit, magnitude 4.2, strong enough to rattle dishes off shelves in nearby Ridgecrest, a town of just under 28,000 people, but not strong enough to cause structural damage. Here's why seismologists are watching closely. This exact region produced 2 significant earthquakes in July 2019, a magnitude 6.4 on July 4th, followed by a magnitude 7.1 just 34 hours later on July 5th. That 7.1 was the largest earthquake to hit California in 20 years. It displaced the ground by as much as 5.5 feet in places, injured close to 100 people, and caused an estimated $5.3 billion in damage across the region, according to figures compiled by the California Department of Insurance and independent catastrophe modelers. Now, a swarm doesn't guarantee a repeat. The USGS is explicit about this. Less than 5% of earthquake swarms culminate in a damaging main shock. But the Ridgecrest fault system sits directly adjacent to the Garlock Fault, a structure that has not ruptured in over 500 years and is capable, according to Caltech seismologists, of producing a magnitude 7.5 or greater event on its own. Meanwhile, 5,600 miles away, Japan's Nankai Trough is under its own microscope. This subduction zone has ruptured roughly every 100 to 150 years throughout recorded history, 1946, 1854, 1707. The Japanese government's own Earthquake Research Committee has stated there is a 70 to 80% probability of a magnitude 8 to 9 megaquake along this trench within the next 30 years. In August 2024, Japan issued its first ever megaquake advisory after a magnitude 7.1 struck off Miyazaki, the same category of warning system now being watched again as recent tremor clusters build in the same zone. And here's the piece most viewers miss. California and Japan sit on opposite edges of the same tectonic system, the Pacific Plate. When stress builds or releases on one side of a 25,000-mile ring of fault lines, it does not mean the other side is mechanically triggered in a simple domino effect. But it does mean both regions are subject to the same underlying process. Decades, sometimes centuries, of slow plate movement suddenly catching up all at once. So let's actually explain how earthquake magnitude works, because most people badly misunderstand it. And once you understand it, these numbers become terrifying in a whole new way. The Richter and moment magnitude scales are logarithmic. That means every single whole number increase represents a 10 times increase in ground shaking amplitude, but roughly a 32 times increase in the actual energy released. Let that sink in. A magnitude 5.0 earthquake isn't a little weaker than a magnitude 6.0. It releases about 32 times less energy. Go from magnitude 6 to magnitude 7, another 32 times increase. From magnitude 6 to magnitude 8, that's roughly 1,000 times more energy released. Not 2 times, not 10 times, 1,000 times. To make that visceral, the 1994 Northridge earthquake, a magnitude 6.7, released energy equivalent to roughly 8 megatons of TNT, comparable to hundreds of Hiroshima-sized atomic bombs detonating at once, though released far more slowly and over a wider area, which is part of why the death toll, at 57 people, was tragically real, but far lower than a true explosive yield of that size would produce instantly. Now scale that up. The 2011 Tohoku earthquake in Japan measured magnitude 9.0, nearly 1,400 times more energy than Northridge. According to NASA's Jet Propulsion Laboratory, that quake was powerful enough to shift the Earth's axis by an estimated 6.5 inches and shorten the length of a day by 1.8 microseconds. It moved the entire island of Honshu 8 feet closer to North America. That's the difference one number on a logarithmic scale makes. It's why scientists don't panic over swarms of magnitude 3s and 4s, but why they watch closely for what those small quakes might be building toward. Now here's the comparison that teaches you everything you need to know about why preparation matters more than magnitude alone. Event A, Haiti, January 2010. Magnitude 7.0. Struck near Port-au-Prince, a densely populated capital with minimal seismic building codes. Death toll, estimated between 100,000 and over 200,000 people according to Haitian government figures, with the World Bank citing damage equivalent to over 120% of the country's annual GDP. Event B, Chile, February 2010, just 5 weeks later, magnitude 8.8. That's not close to Haiti's 7.0, remember the logarithmic scale. An 8.8 releases roughly 500 times more energy than a 7.0. By every physical measure, Chile's earthquake should have been catastrophically worse. The death toll in Chile, 525 people. Same general region of the world, same year, same 5-week window. One earthquake, 500 times weaker in energy release, killed up to 400 times more people than the other. Why? Building codes. Chile had rebuilt its national seismic code after a devastating 1960 earthquake, still the largest ever recorded at magnitude 9.5, and enforced mandatory reinforced concrete standards for decades afterward. Haiti, one of the poorest nations in the Western Hemisphere, had almost no seismic code enforcement at all. This is the single most important lesson seismologists want the public to understand. Magnitude does not determine death toll, infrastructure does. California, for all its fault lines, has some of the strictest seismic building codes on Earth, updated repeatedly since the 1971 San Fernando earthquake and again after Loma Prieta in 1989 and Northridge in 1994. That's not a guarantee of zero damage. But it is the reason a magnitude 7.1 in the Mojave Desert in 2019 produced a death toll of 0, while comparable-sized quakes elsewhere in the world have killed tens of thousands. Here's something almost nobody knows. California actually gets shaken by more than 10,000 earthquakes every single year, according to the California Geological Survey. Only about 15 to 20 of those are strong enough for people to even feel, and only one every year or two causes any real damage. And here's an even stranger fact. The state's seismic network, run jointly by the USGS and Caltech, now includes an early warning system called Shake Alert. It can't predict earthquakes before they happen. No system on Earth can do that reliably, despite what conspiracy pages will tell you. But it can detect the first, weaker P waves of an earthquake and send a warning seconds before the stronger, more destructive S waves arrive. In 2019, Shake Alert gave residents in Los Angeles a full 30 seconds of warning before shaking from a Searles Valley earthquake reached the city. 30 seconds doesn't sound like much. It's enough time to drop, cover, and hold on before the real shaking starts. And that gap has already been credited with reducing injuries in multiple events since the system's rollout. Now let's address the conspiracy angle directly, because I know it's already in the comments before I even finish this sentence. No, HAARP does not cause earthquakes. HAARP, the High Frequency Active Auroral Research Program, is a real, now largely inactive ionospheric research facility in Alaska, but its transmitters operate at power levels literally millions of times too weak to influence tectonic plates that are miles below the Earth's crust and held together by forces of unimaginable pressure. The USGS has stated plainly, on the record, that no human technology exists capable of triggering or preventing earthquakes. What is actually happening is simpler, more scientifically grounded, and honestly more interesting. Plates that have been grinding against each other for millions of years are just doing what they've always done. No secret weapon required. So where does that leave us? A swarm in California. A megaquake advisory zone active in Japan, a Pacific plate under constant, silent stress on both sides of the planet. None of this means a catastrophic earthquake is guaranteed tomorrow. But it does mean the science is telling us, loudly, that preparation isn't paranoia, it's just math. Here's your practical checklist, based directly on guidance from the USGS and FEMA's Ready.gov program. 1. Secure your space. Anchor heavy furniture, water heaters, and bookshelves to wall studs. Falling objects, not collapsing buildings, cause the majority of earthquake injuries in developed countries. 2. Build a 72-hour kit. 1 gallon of water per person per day, non-perishable food, a flashlight, a battery or hand crank radio, and any needed medications. 3. Know the drill. Drop, cover, and hold on. Drop to your hands and knees, take cover under sturdy furniture, and hold on until shaking stops. Do not run outside during shaking. Most injuries happen from falling debris near exits and windows. 4. Identify your building's seismic risk. If you live in a pre-1980s structure in a seismic zone, look into a retrofit inspection. Many California cities offer low-cost or subsidized retrofit programs. 5. Download an early warning app. Shake Alert-powered apps like MyShake are free and can give you critical seconds of warning. 6. Make a family communication plan. Choose an out-of-state contact everyone can reach if local lines are jammed. None of these steps are dramatic. None of them require panic. They just require 5 minutes of your time today before the ground decides to remind you why they matter. So let me ask you directly, have you ever actually felt an earthquake, even a small one? Tell me where you were and how strong it felt in the comments below. I read every single one. If this video actually taught you something new about how earthquakes really work, do me a favor and hit like. Let's get this to 10,000 likes so more people see the real science instead of the conspiracy noise. And if you want to be here the moment the next major seismic event breaks, hit subscribe and turn on notifications, because at Infinity Alert, we cover it before it's everywhere else. Stay curious, stay prepared. I'll see you in the next one.